Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyzone Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home. Welcome back to another podcast, and in this podcast we're going to talk about debunking Wi-Fi 7. So now that Wi-Fi 7 has become a little bit more mainstream, it's certainly, we're starting to get...
Yeah, people are still going to use it more and more, because it's quite popular. We've introduced the 660, end of last year, was it even? We were the first even, and that will do the Wi-Fi 7 introduction. And afterwards, we came with the 130, and that became very popular with our customers. And that popular that people are using it quite often now and got some feedback to us. And they have some questions about the functionality, how to deal with the configuration and with the things that pop up during their setup with their customers.
So there's quite a lot of, I would say, Wi-Fi 7 standard questions, more to do with around Wi-Fi 7, the access points and how they operate.
Yeah, and some are related with the traditional technology, of course, but especially on Wi-Fi 7, people get questions. So I think to clarify this, I think we should get Hugh Simpson on board, our MDM for Wi-Fi, because he's the expert in Wi-Fi to have any clarification on this, I think.
So welcome back, Hugh.
No, thank you for having me back. It's always good to be here. Let's start looking at our range. As Michelle said, we started with our WBE 660 last year, and we were the first to come out to the market. That is a 4x4 triple radio access point. And then we also have the latest one, which is our NWA 130BE, which is a 2x2 triple radio access point. So they're very complementary of each other. But what's the main difference? Okay, so as I kind of, if we can spot between, not just the numbers, etc., but the number of antennas. So they're both triple radios. The NWA 130BE has 2 times 2 antennas on its 3 radios, and the WBE 660 has 4 antennas on its 3 radios. And what's the main difference? This gives the 660 the advantages in the fact that it's got 4, let's say, mouths and ears to hear with, whereas our NWA 130B only has 2 mouths and ears.
But there's a lot of hang up on Wi-Fi 7, about the frequency, right? About the triple band element where it's using all 3 elements. But actually, if we separate those, right, because they're 2 different things.
Yeah, we should always separate the frequency and the standard apart, okay? So, a lot of people get caught up with the 6 gigahertz. Okay, 6 gigahertz means that it's Wi-Fi 7, or Wi-Fi 7 has to only run on the 6 gigahertz frequency. Let's split that apart. The frequency is the frequency. Okay,
the standard is separate from that.
And the standard is the standard. So
100%.
we obviously have 2.4, we have 5, and we have 6. Okay, frequencies, gigahertz frequencies, and we have Wi-Fi 6, 6E, and Wi-Fi 7.
Will tell us how we use those 3 frequencies.
Correct. That's absolutely correct.
And, we should mention that Wi-Fi 7, Wi-Fi 6, etc., their real kind of standard is 802.11be. And there's AX and AXE as well, right? So for those, so there's not any confusion over what we're talking about, right?
Yeah, but they commercialized it, so that's gives more clarity to the user, and that's why we're using Wi-Fi 6 and Wi-Fi 7.
Yeah, but we still hold those letters in our naming convention.
Right? Yeah, absolutely, yeah. So why don't we talk a little bit about the standard and why it's so important versus, we talk about frequency, right, and we put that to one side. So what are the real benefits in Wi-Fi 7?
So one of the main reason for any of these new standards that ever come out is ultimately speed. Okay. And speed requires you to be connected with the best quality. Okay. So now we talk about quality over Wi-Fi. Okay, and that's really key and really important. And going back and taking this back to the number of antennas, for instance, to get the best experience for our clients, the more antennas, the more mouths or the more ears we have, the better the experience is for the client. And therefore, we're going to provide that client not only the range, but also the speed and the quality of.
So, in some of the standards in the past, right, there's been this 2x2, 3x3, 4x4. So in Wi-Fi 7, the main stream access points today, there are 2x2 and 4x4, whereas previous standard they had a 3x3, and so just to make it clear for everybody today, there is only really in the mainstream a 2x2, 4x4. Technically, there could be an 8x8, a 16x16 in the Wi-Fi 7 standard, right? So, and obviously under this, this 2x2, 4x4 is about making the efficiency in the air and using some of those technologies from Wi-Fi 7 standard. And what I think we really should give the listeners is some of those key features. I mean, we talked about the speed.
The speed comes from we could talk about higher modulation. QAM, for instance, is the technical term for it. Ultimately, that gives us better throughput, etc. There's the client. If the client is close enough to the access point and has the best connectivity and quality, you will get the better throughput and the better speeds. As the client moves away, ultimately the modulation drops off, that QAM drops off, and therefore you fall back to older standards.
And the QAM is the density of the amount of data that we're transmitting. Yeah, for people that don't understand what the QAM is doing, but it's compressing your data in a less time, and therefore you have a higher transfer. That's what they're doing.
Yeah, for sure. It's like getting more data out of the same amount of space, right?
Exactly.
Yeah. So, I mean, without going too technical in our podcast, right?
Yeah.
So, but yeah, it's about getting more efficiency out. And we did do a podcast about Wi-Fi 7's actual standard, and also we've done a few various podcasts on 2x2, the spatial streams, etc. So more technical information for those who want to dig a bit deeper into that. But for this, we're trying to debunk some of those common problems or things that people didn't understand about Wi-Fi 7 when they went to deploy them as well, right? So
again, will I receive a better signal? Will I receive a faster speed, etc.? That is always one, okay? And that's, ultimately, that is the goal. That is why we're deploying Wi-Fi 7 over Wi-Fi 6 and Wi-Fi 5. You will get better speeds. The other side is, the number of clients that we can support. Ultimately, if we are communicating faster, we're communicating more data, we can handle more clients on our access points.
Yeah, and obviously, if we take some of the Wi-Fi 7 standard, we're much more efficient over the over the air itself, right? So means that dealing with more client devices is much more efficient. So this is a really nice part of the standard.
Yeah, I think the benefit of more clients is really, really significant. But I think the best feature that Wi-Fi 7 can bring is not the speed. I think, it's nice to have more speed, but I think that we can provide some redundancy as well in the Wi-Fi 7 standard, isn't it?
Oh, and reliability, right?
Yeah.
And reliability, yeah.
So, the feature that we're talking about here is MLO, multi-link operation. This allows the client to communicate over multiple frequencies at the same time. So again, whereas in Wi-Fi 5, Wi-Fi 6, etc., a client would only connect, let's say, to the 5 gigahertz range or the 2.4. Okay, it will be one or the other. MLO allows the client to connect to maybe 5 gigahertz and 6 gigahertz. Okay, so again, increasing the bandwidth and also increasing the resilience. So if one of those frequencies suddenly had a interferer come in or another user transmitting lots of data, therefore, if it was the old standard, our client would just drop off or would have a bad experience. Now with MLO, because we have that redundancy and resilience, etc., we can use one or the other and both.
But one thing you should remember as well is WPA3 as well, right?
You cannot run MLO without WPA3, yeah.
You can't run Wi-Fi 7 without WPA3. So
Thank you for your clarity, Hugh, on this one.
So to ultimately to achieve not only the QAM, the MLO, and all of the features, we have to support WPA3.
No, I think the WPA3 needs some clarification because majority of people will probably use the WPA2 preset key as the main security feature nowadays. But you need to remember, if you go to Wi-Fi 7, you have to go to WPA3 in this case, and that is not downwards compatible or upwards compatible. It's how you look at it. So make sure that all your clients that are connecting have that capability as well. Yeah.
Yeah, absolutely. So you can, though you increase the security level, to a much, much higher standard, there's still a mix of devices out there that don't support WPA3.
Yeah, you cannot mix WPA2 and 3
exactly.
together. Yeah, won't do it.
So let's be very clear on that though. And one of the myths, etc., is can my Wi-Fi 7 access points be backwards compatible?
Well, I mean, the answer is technically yes.
Absolutely it can. You just won't get the Wi-Fi 7 standard being transmitted. So again, you can have an SSID that is transmitting on Wi-Fi 7 or with WPA3 as a standard security. So therefore you're making sure that your clients have the opportunity to use Wi-Fi 7 standards. And you can have another SSID that maybe has a lower security, WPA2, for instance, pre-shared key. And therefore they would only ever get a Wi-Fi 6 standard.
So there's quite a lot of information there about, the debunking of, and this is quite a common misconception. People don't understand that there's a change in the, the WPA part as well, right? To actually get the real speed. Well, you don't get the speeds or the MLO or the QAM, elements out of Wi-Fi 7 without doing this, right? So it's a nice little, I would say, bite-sized information pack there for people who are trying to deploy Wi-Fi. So then we go on to dual band access points versus triple band.
Yeah.
Exactly.
Yeah. So if we take a look at our older generations, Wi-Fi 5, Wi-Fi 6, for instance, these were always dual radios. So we only had the standard or only had the opportunity to use 2.4 and 5 gigahertz. With, the evolution of Wi-Fi 6E, for instance, and the E being extended, etc., we had the opportunity to utilize the 6 gigahertz frequency. We continue that into Wi-Fi 7. Okay. But again, remember, Wi-Fi 7 doesn't need 6 gigahertz and 6 gigahertz doesn't need Wi-Fi 7 to operate. They are two different distinct features or frequencies, etc.
So what you mean, a dual radio can be easily a Wi-Fi 7 AV? Correct.
And that's exactly where we're getting to on this. So where we have the triple radio access points now with the NWA 130BE and the WBE 660S, they are triple radios. They operate on 2.4, 5 gigahertz and 6 gigahertz all at the same time, or at least have the opportunity to have those configured. Whereas a dual radio device would have 2.4 and 5 or 6 gigahertz.
Also, we need to remember 6 gigahertz, no outdoor at all. So if you have any outdoor area, then in this, even if you want to operate Wi-Fi 7, right? Like we say, we split it. You would need to use it in the 5 gigahertz and the 2.4 gigahertz. You wouldn't be able to use 6 gigahertz. So, and the definition for operating outdoor Wi-Fi is if it's got a removable roof, retractable roof, or anything like that.
Yeah, there's considered the outdoors.
Yeah, there's no getting away from it. There's no kind of, let's close the roof sometimes and it being there. No, if it's got visibility of outdoors, then it's outdoors.
Well, a question for you, Hugh. We're talking about dual radio Wi-Fi 7, but I don't see anything at the moment. Can you say something about it? Will it happen, or how does it work?
So ultimately, we got some new access points coming in our roadmap, and they will be dual radio Wi-Fi 7 devices. Now, whereas in Europe, we have the luxury of using half of the 6 gigahertz frequencies. There are certain parts of the world that don't and can't use the 6 gigahertz. So a dual radio is a great opportunity for those areas, and even for Europe, etc., where you want to expand or want to utilize just the 2.4, the 5, or the 2.4 and the 6 gigahertz options. They are available to us.
So you may remember, 2.4, we always talked about it's very cluttered environment, but even under Wi-Fi 7, it's the frequency is, is still very important. And let's be honest, I don't think in the immediate future we can really remove 2.4.
Yeah, but think about devices that need to have connectivity with low speed. Think about IoT devices. Yeah, you need the distance to connect. Yeah, if you take it into a home environment, maybe you have a Wi-Fi door sensor. Yeah, and you cannot have an access point close to every door. So then coverage is key, that you can connect to such a device on 2.4. Of course, you could say, the bandwidth is maybe quite limited. But it is only to send a signal the door is open or closed. So the requirement is almost nothing. So therefore, the 2.4 is still almost a mandatory frequency that we still need in the future.
When you look at the Wi-Fi 6 standard, they actually had quite a bit of functionality for IoT for low power. The timing slots, so they didn't keep coming in as frequently, so we need to check in. So to help devices with low power, right? So
2.4 gigahertz isn't going anywhere, right? It's here to stay. There is a lot of legacy devices out there that utilize this, and it does have its advantages, right? So again, we talk about clients using it, IoT devices, and what we're talking about there is distance. Okay, so again, the 2.4 gigahertz does go further than either the 5 or the 6 gigahertz frequency.
Also our smart antenna leverages from it, right? So it uses 2.4 to establish the connection, then modulate up into 5 or 6, right?
And then hand it over to a better frequency.
That's right, yeah. So, part of the whole adaptive radio technology, it utilizes the distance to grab the client first and then modulate up. So there are lots of advantages still using 2.4, right? And obviously now in the Wi-Fi 7 standard, it's much more efficient anyway. So we're not saying it's the best frequency by a long shot, but it's still going to be there, right? So I have a question to you. Long range Wi-Fi.
So long range, or 4x4 antennas, for instance.
I guess so, right?
But long range is not just power up the power?
No. So we never try and put access points on full power out there. We always try to lower the power down. Ultimately, that's to allow the clients a better experience on there. But long range, so the terminology long range or 4x4 antennas. So some of our dual radio and access points that will be coming will have a 2x2 on the 2.4 gigahertz range, and then we will have a 4x4 on the 5 or 6 gigahertz range. This gives us the range. Okay, so again, going back to the very beginning of this conversation, we talked about ears and mouths. Okay, so 4x4, I have 4 mouths. So when I shout, I don't shout 4 times louder, I just shout 4 times. Okay, in 4 different directions. And your clients off the reflections will pick up the best 1 or best 2, depending on how many antennas or how many ears it has, those signals. So it gives the client the best opportunity. And vice versa, when the client speaks back, remembering that the client might not have the same power, the same ability as the access point. When it shouts back or when it talks back to the access point, we've got 4 ears to hear it with. So therefore, we can pick up the best signal.
It's highly unlikely it's got more power, right?
Yeah, but it's just trying to hear back, and it allows the device to work further away. So the more antennas, the more that we have, the better and the further, the longer range that we will be able to hear.
Yeah, so a lot of people think the more antenna is only more speed. but that's wrong. Yeah, it's not only speed; it is definitely also better coverage that you bring in your environment, isn't it?
Yeah, absolutely. I think, like Hugh mentioned, when you are listening, for a device that is transmitting, and so, you definitely can receive the strongest signals, right? Like Hugh mentioned. And the benefit of this is it gets to pick the best signals and then takes those. So, in the end, it's about reliability, coverage, range, right? And the reliability is increased as well by doing this. So not only the coverage is better, so it's longer range technically, it's also reliable as well. And ultimately, out of all of these things in Wi-Fi that we keep doing, we say faster, we say more clients, but actually nobody remembers all those things. They remember the reliability. So it's all about trying to make it more reliable, right?
And the quality of the experience.
Yeah, exactly. Yeah.
It is all around that now. How not only, we can pretty much always connect, right? So that's great. It's about how that experience is for the user.
No Wi-Fi is better than bad Wi-Fi.
I believe that's my saying.
That's yours, yeah. A wise man once told me.
Yeah.
So Hugh, you mentioned there's some more APs coming. So Wi-Fi 7 series?
Yeah, we have 4 new access points coming along, combinations of 2x2s, 4x4s. These are dual radio access points. So with our band flex, what the band flex gives us is it gives us the ability of either selecting the 5 gigahertz or the 6 gigahertz frequency. Now, you might look at it and go, why do we need that? What is it for? Why can't we have triple radio? Well, if you want triple radio, we have triple radio access points as well.
Just buy it.
Yeah, they're already here.
Yeah, but I think it's a great way to start with 2.4 and 5, as majority of your clients are still running the 5 gigahertz, but your device is future-proof. On the way, you're upgrading your devices, your phones, your laptops, that they are capable of running the 6 gigahertz frequency. And then you can switch on the AP on the 6 gigahertz, and then you leverage from much better Wi-Fi, better Wi-Fi experience. So I think it's a very good product and gives you a future-proof investment if you don't want to buy a triple band, of course, because then you got everything.
So I guess the last question I have then is the coverage of 5 gigahertz versus 6 gigahertz. Then this is the one that's brought into a lot of conversation, right? But reality, yes, it's not quite as good, and it does get absorbed by walls slightly more, or by materials slightly more. But the coverage,
if you wanted to put a figure on it, because I think that's what people are asking for, people are wanting, it's about 10% worse than 5 gigahertz. Okay, I'm gonna put a statement out there. Yeah, will you notice it? Will you experience it? Will you see it? And always with Wi-Fi, it's very hard to measure, right? Unless you're going out with site survey kit and actually doing a full survey. Just to put that statement out there, it's about 10% worse.
Yeah, the difficult thing is if, let's say, your signal strength is weaker on the 6 gigahertz, it can be even as a benefit that your bandwidth that you are being given is much larger. So although the signal strength is lower, but your bandwidth is higher, without any interference, you could end up with the same speed or maybe even higher speed.
Well, I think under Wi-Fi 7,
theoretically.
Yeah, under Wi-Fi 7, I mean, you obviously the modulation is much smaller. So, for example, in previous standards, the jump of modulation was massive, right? It would jump bigger. So now you're probably less likely to see it, right? Because the modulation itself, we're talking about the QAM bit. We're not going to go into the depths of QAM, we mentioned it earlier.
Yeah.
But it means like, before it would have taken a big jump from like 100 to 150 to 200 kind of jumps, right? But now it will take maybe 5 or 6 megabits per second, differences.
Yeah,
So.
especially on Wi-Fi 7. I think maybe the gap is even smaller. I don't want to put a number on it because I don't want to argue with our expert. But yeah, that's my gut feeling about this.
Yeah. So anyway, that's a lot of information to take on board, and I think we covered quite a bit of ground there. There's obviously always more questions than that we get, but that's a good amount for this podcast today. So I think thank you very much, Hugh, for joining us and answering these questions.
Yeah, and thank you for all the listeners to give us feedback about the product that we've been using in the last couple of months with our new Wi-Fi 7 products.
So thank you very much.
No, thank you.